loan. So annuities, there's also the annuities formula, or the annuities future value formula, which is again the case where we don't have to use a recursion. And this is what we have here. So to define our variables, A is the amount in the annuity. So we're still talking about annuities, but this is just the formula instead of using a recursion. M is the periodic deposit. So for example, $200 a month. I is the decimal interest rate per period again. So if it was 8% per annum, I would be 0.08. N, number of compounds. And then the annuities future value formula is asking the question, how much will our regular investments of M, how much we're periodically depositing, grow to after N time periods? So how much money is pretty much what's our future value going to be of this annuity if we keep investing this amount of money over this amount of time? And the interesting thing to note is that this formula only works if the initial value is $0. Otherwise, we need to use the compound interest formula as well. And that's because if we have, for example, an initial value of $20,000, we can't just add on the $20,000 at the end, and this formula doesn't take into account the $20,000 because interest would also be being applied to the $20,000. So we'd have to think about, well, okay, how much are we earning from this, but also how much compound interest would we have earned on our initial value as well? So let's do a question to demonstrate that. Suppose we have an initial balance of $30,000. Interesting, we're going to have to use the compound interest formula as well as the annuities formula. And we deposit $1,000 at the end of every month. So we're looking at monthly. And interest is compounding 6% per annum. How much will be in the account after 5 years? So we have our annuities future value formula. We know that M, the periodic deposit, they're adding $1,000 every month. We also know that I, the interest rate, is the decimal rate of interest, 0.06, divided by the number of compounds, monthly, 12 per year, gives us 0.05. You can see also the 1 is built into the formula here as well, so we don't need to add the 1. Then we have N, the total number of compounds. So we have 5 years, 12 months a year, so we've got 60 compounds in total. And then from there, we can just substitute into our formula. So we have A equals 1,000 and the rest of our numbers that we've substituted nicely in. And the awesome thing about calculators is they can solve equations like this for us. So the future value of this annuity is $69,770.03 because they invested $1,000 every month for 60 months. So you can see that's where the $60,000 came from. And then the $9,770.03 is the interest that they would have earned from that. But off the back of what I said earlier, this would assume that there was no money in the annuity to begin with, but that's not true. So this is why we need to use the compound interest formula as well. So back to our friendly compound interest formula. So we have our initial value was $30,000 and it's growing by a factor of 1.005 and it's going to do that 60 times over. And that gives us $40,465.50. So you can kind of see there's these two elements here. This is the money from our regular periodic deposits plus the interest based on that. And this is our initial amount, $30,000, plus the almost $10,500 of interest that they've gained on that initial amount. So to get the actual true, fully everything included final value of our annuity, we've got to take into account this value here and this value here, which will give us a total of $110,435.53 after 5 years. So that's why when we have an initial sum in an annuity, we need to consider both the compound interest formula and the future values annuity formula. So I hope that one made sense for you. Another trial exam question. So a plumber wants to invest his earnings into a fixed term account. He opens the account and deposits $2,300 per quarter, 2.86% per annum, compounding quarterly. how much will be in the account after 5 years. So this sounds like a perfect scenario for the future value of the annuities formula. This is almost exactly what we did before. The future value is unknown. We know that M, the deposits he's making every quarter, is $2,300. So we've got that sorted. We know that I is again 2.86 divided by 100, and then we're also dividing by 4 because it's quarterly compound. So that's like our M value, and that gives us our decimal rate of interest. And then we can substitute into the equation, and that'll give us our answer, and we can see that that is $49,262.76. So that's how I'd use the future values annuity formula to solve this question. So that's pretty similar to what we just did before.